Alright, I'm gonna do chapter 8, number 3. The question is, a bead slides without friction around the loop-the-loop. The bead is released from a height h equals 3.50 r. There are two parts to the question. Part A is, what is the bead's speed at point A, which is right here. And B is, how large is the normal force on the bead if its mass is 5 grams. Alright, to start off, the initial picture is right here. The ball starts right here. And the final picture, the ball ends up right here, which is for part A. So, first you're going to be using the equations from the total mechanical energy. So you would get E initial equals E final. So then, simplifying that equation, you would get K final plus U final equals K initial plus U initial. And since we already, and for the equation K final, you get 1/2 mv final squared plus mgy equals 0, because the velocity of the initial for the initial picture is 0 because that's where it starts. So there's no velocity in the beginning, and it is stated that the initial velocity is started at the top. So that would make this 0. Add that to mgh. Because all of them have an m, you can just take it out. So it would be like that. And simplified, it'd be 1/2 v final squared plus gy equals gh. Moving the gy to one side, you would get 1/2 vf squared equals gh minus gy. And you can simplify that so that v final is by itself. So it'd be v final equals square root of 2 times g times h minus y. So plugging in the equations for h and y, you would get v final equals 2g 3.50 r minus 2r, and square root of that. And to simplify it, you would get vf equals square root of 3gr. Now that would be the final speed for the bead at point A because of all everything solved for. Now that's the answer of part A. Now for part B, it asks for how large is the normal force on the bead if its mass is 5 grams. Now to start off, the picture or the free body diagram would look like this. Since it's on the top right here, it'd be a curve, and then the forces would be pointing down. Mg would be pointing down, and also the normal force would be pointing down. And according to Newton's second law, the equation for that would be N plus mg equals mv squared over r. And for here we have mass is 5 grams and the height is 2m. And we gotta change the grams into kilograms, so it'd be 5.00 grams equals 0.005 kilograms. Now for here, we would move the Newton to its own side, so it'd be Newton equals mv squared over r minus mg. Now simplifying the m to move it to its own side, it'd be n equals m parentheses v squared over r minus g. And keep simplifying, we would get m parentheses, and you could plug in v squared from what we got before. So it would be 3gr, because before for the v final we had it square root, but here it is squared. So over r minus g, and both the r's cancel out. So it'd be m 3g minus g. So it would basically be 3m times 2g. So it'd be 2gm. And plugging in all the equations for that, or all the variables, n would equal 2 times 9.8 meters per second squared times the mass, which would be 0.005 kilograms. Solving for that, it would equal 0.098 newtons downward. And that is how you solve for chapter 8, number 3.